In today's lesson, we're going to model using the three-point method in quadratic functions and equations. So our question posed is, how could you write the equation for a parabola if you only knew 3 points on the curve and none of these were the vertex? So I think what we could do is we could look at the fact that this graph is passing through 2, -3, and 3, 3, so we know this, 3, 3, and we know 2, -3, and we know -1, +3. So the first thing I notice is that these points here, the -1, 3, and the 3, 3, have to be equally spaced across our x equals h line. So I think they're spaced 1, 2, 3, 4 spaces. So 2 away would be our vertical break, that x equals h line. So I want to start by drawing that. So I know my h value has to be 1 based on the fact that these 2 points are mirror images of each other across that axis of symmetry. Using that same kind of thinking, our point at 2, -3 is 1 unit away, so we also would have 1 point right there. So that way we know that the x equals h line is at 1, and we know that our c value is at -3, and I believe we could tell that our vertex must be at -5, and the way I know that is based on the fact that parabolas have a 1, 3, 5, or odd pattern stepping up. So if we look at the distance between this point here and this point here, and then this point here and this point here, this would be my step of 1, this would be my step of 3. But because this is by a factor of 2, and this is by a factor of 6, 1, 2, 3, 4, 5, 6, that a value must be a stretch of 2. So we could put this puzzle piece together this way and come up with a formula for our parabola. So it looks like my parabola is going to have the shape that goes smoothly through these points to the right of 1 and smoothly through these other points to the left of 1, and the vertex is located at 1, -5, and my c value is -3, so I could write the equation in vertex form: y equals a times x minus h quantity squared plus k, and know that we had a stretch of 2, x minus 1 quantity squared minus 5. So that's one approach, just by problem solving and knowing some of the characteristics of a parabola. That's not the only method, but that is one method. Here we're going to try a little something more algebraic. Let's say we have a parabola that contains these 3 points given, and we want to create a system of equations that would help us solve for the a, b, and c values. Now to do that efficiently, I want to use the ax squared plus bx plus c equals a number, and the way we could do that is first using this as my x and y, ax squared plus bx plus c equals my y value 3. And then do that again for ax squared plus bx plus c equals -3 for this y value, and ax squared plus bx plus c equals +3 for this y value. So what goes where my parentheses are? Well, those are our x values. -1 here, +2 here, and +3 in the third case. Now we just need to simplify those equations a little bit, and we will have a system. So putting that together, we're going to have a This equation would be A minus B plus C equals 3. The second equation would be 4A plus 2B plus C equals negative 3. And then our third equation would be 9A plus 3B plus C equals positive 3. And I like to number my equations to keep myself organized. So let's say we take equation 2 and we multiply equation 1 by negative 1. So we're going to subtract equation 1 from equation 2. 4A plus 2B plus C equals negative 3. We're going to subtract A and add B and subtract C and subtract 3. That way we're eliminating the C term. And then this new equation, we'll call that equation 4. We could also divide equation 4 by 3 and simplify that down a little bit more so that we have A plus B equals negative 2. So this is my equation 4. Next, we could have equation 3, and we could add equation 3 to equation 2. So let's see what that would look like. So we want to do 4A. Let's subtract 4A minus 2B minus C equals positive 3. So we took equation 3 and we subtracted equation 2. And again, we're eliminating the C term. So 5A plus B equals 6. And we're going to call this equation 5. So if we take our equation 4 and our equation 5 and put those together, we would have 5A plus B equals 6. And we could say minus A minus B equals positive 2. So 4A equals 8, and we know now that A equals 2. So if A equals 2, 2 plus B is negative 2. So our B value is negative 4. And then if we go back to equation 1, we could have solve for C. So if A is 2 and negative B is negative 4, so that's plus 4, and C, and then that equals 3. So 6 plus C equals 3. That means C is negative 3. Now I need to erase a little bit so that we can record our parabola. So we know A is 2, we know B is negative 4, and we know C is negative 3. Okay. So over here on the left, we're writing our equation. Y equals 2x squared, and B value is negative 4, and C value is negative 3. I wrote that in error. That should be negative 3. So we have used that 3-point method algebraically without a graph and found the equation in standard form, where our first one was in vertex form. So let's move on to something a little different now. In example 2, I'd love for you to grab your calculator. We're going to use the matrix method here. So using a matrix on the calculator, we're going to first write the system of equations. So we have the 3 points, A times 1 squared plus B times 1 plus C equals negative 2. That used this point. The second point, A times 2 squared plus B times 2 plus C equals negative 4. That used this point. And our third equation, A times 3 squared plus B times 3 plus C equals negative 4. So you can see here there's some symmetry going on. So we have 3 equations, And our matrix that we would want to put on our calculator, now I'm just doing this in my head, that's 1a squared plus 1b plus 1c, and that's going to equal -2. In the second row, we have 4a, 2b, 1c, that equals -4. And in our third row, we have 9a, 3b, 1c, and -4. Next, you need to grab your calculator, and I'm going to walk you through the steps on the TI-84 for this example. So the TI-84. So the first thing you do is press the second button, and then the X inverse, because you'll see right above that button it says matrix. Then you arrow over to edit, and I'm going to choose matrix A, and I'm going to name matrix A as a 3-row 4-column. And you can see here that this is a 3x4 matrix up here. And then we are going to enter all of the elements. So you'll enter 1, 1, 1, -2, 4, 2, 1, -4, 9, 3, 1, -4. Now we need to get out of there, so you press second mode, which is the quit key, second mode. And next we're going to go back to second and matrix. So again, the X inverse button. And this time we want to perform some math. So arrow over to math. And then you want to either go down, or I prefer to go arrow up since it's closer. And we want to find the reduced row echelon form. So you're looking for that, which is letter B on our calculator. When you press the letter B or that, it'll open up that RREF. So it'll open up on the calculator screen, RREF, and your cursor is blinking right here. So we need to tell it that we want to put matrix A in there. And the way you do that is you press second, X inverse again, and you see our number 1 that says letter A is a 3x4 matrix. So you press number 1 and the blinking cursor stops and it places in its place right here. It's going to put the letter A, or matrix A. It'll look just like that. And then you press enter. And when you press enter, it's so magical. You're going to see our reduced row echelon form, with the first column being 1 and 2 zeros, the second column being 0, 1, 0, the third column being 0, 0, 1, and then we have our A and our B and our C value. So here's the value for A, this is our B value, and this is our C value. So we know the equation for our parabola is 1x squared minus 5x plus 2. Now, I would highly recommend that you go into the graph window and graph that parabola and check to see that you definitely have these 3 ordered pairs in your table for this parabola. So again, this is our procedure over here, how to go about doing that with the TI-84. In example 3, let's use the quadratic model so we can do the same thing here with the calculator to enter that matrix. So we've got, using the ordered pair 1, 3, we have A times 1 squared plus B times 1 plus C equals 3, and A times 2 squared plus B times 2 plus C equals 5. That takes care of that point. And finally, A times 3 squared plus b times 3 plus c equals 6. So that's our third ordered pair. And putting that together into a matrix, our matrix would look like row 1 is 1, 1, 1, 3, and then 4, 2, 1, 5, and then finally in our last row, 9, 3, 1, and 6. And if you go back to your procedure and perform that operation with your calculator, your reduced row echelon form is going to give you negative 1/2, 3.5, and 0. So our parabola is y equals negative 1/2 x squared plus 3.5x. And then the question that was being asked to us in this setting was that the top of the goal cage is at 5, 6. So we want to know, will the ball go over the goal? And if not, will it hit the goal? And explain how we know. So what we see is that when the ball, when x is 5, messed that up. We know when x is 5, y is 5. We know that from here. And the ball will be below the goal cage. So if you could imagine for a minute, if 5, 6 is where the top of the goal cage was, and the red is the path of the ball, then the guy kicking the goal got the ball into the cage and scored the goal there. Okay, in this example, we want to use the graphing calculator to find a quadratic model for the predicted temperature in San Francisco. And I've written the procedure for the TI-84, but I'm going to model on my Inspire over here. So the first thing I want to do is I want to add list and spreadsheets. And I'm going to put the x-axis as my time. I'm going to start out 8 a.m. as the 0 time. And then 10 a.m. would be 2 hours later. And then 12 would be 4 hours later. 2 p.m. would be 6 hours later. 4 is 8. And then finally, our last one is 10. And then back to the top, we want to call the y-axis in column B. And we need our temperatures here, so 52 degrees, 64 degrees, 72 degrees, 78 degrees, 81 degrees, and 76 degrees. Next, you go Control and I. We're going to add data and statistics, so hovering over the x-axis, we'll put the time there. Hovering over the y-axis, we'll put the temperature there. Under Menu, press Analyze and Regression, and we want a quadratic regression. So we want to write this equation down. Y equals -4. So we're going to write this equation. Y. So we have our equation up here, 4.6875x squared plus 7.21x and 51.607. So using that calculator equation and going to our regular graph window and graphing to find the maximum value, we find that the maximum happens at about 7.69 hours. So this was 8 hours, and 7.69 would be around 3 p.m. when that maximum would occur for San Francisco. Now, example 4 is another example like we just saw in San Francisco. And if you enter these data points into your table, I used 6, 9, 12, 15, 18, and 21 for my x-axis. And then I used the other values for the y-axis for temperature, inserted the data in spreadsheets, and did the regression equation. My TI-84 got these values. We're really close on the Inspire using this set of data. Then finally, on our last example, we have some speed. It's the extension question, and the table gives the stopping distance for a car under certain road conditions. So in my X column, I put the speed 20, 30, 40, 50, and 55. In the Y column, we put the stopping distance data. And the first thing I did with the regression was to find a linear model. My linear model on the TI-84 gave me y equals 3.157x minus 52.335. And then the quadratic equation gave us y equals 0.0424x squared minus 0.041x plus 0.889 for the C value. And that is the end of lesson 3.